In this session, we are going to discuss Fourier series expansion of function defined in the interval 0, 2 pi. Look at the given question. Write the Dirichlet condition for the existence of Fourier series. Also find the Fourier series to represent f of x is equal to x square in the interval 0, 2 pi. What is given here? We are given the function f of x is equal to x square defined in the interval 0, 2 pi. We are asked to write down the Dirichlet condition for the existence of Fourier series, and we are going to find the Fourier series expansion of the given function. Shall we write down the Dirichlet condition? F of x can be developed as a Fourier series. F of x is equal to a0 by 2 plus summation n varies from 1 to infinity an cos nx plus summation n varies from 1 to infinity bn sin nx, where a0, an, bn are constants, provided f of x is periodic, single valued and finite. F of x has a finite number of finite discontinuities in any one period and has no infinite discontinuities. F of x has at the most a finite number of maxima and minima. Shall we find the Fourier series expansion of the given function? The function is defined in the interval 0, 2 pi. What is the Fourier series expansion in the interval 0, 2 pi? F of x is equal to a0 by 2 plus summation n varies from 1 to infinity an cos nx plus summation n varies from 1 to infinity bn sin nx. We mark this as equation 1. Here a0, an, bn are constants defined as a0 is equal to 1 by pi integral 0 to 2 pi f of x dx. An is equal to 1 by pi integral 0 to 2 pi f of x cos nx dx. Bn is equal to 1 by pi integral 0 to 2 pi f of x sin nx dx. Now we are going to find the values of a0, an, bn. We first find a0. You start with the formula of a0. F of x is defined in the single interval 0, 2 pi. Substitute f of x value here. F of x is equal to x square. Shall we integrate this? We keep 1 by pi as it is outside. Which formula can we use for integration? Integral x power n dx. Tell me the formula. Integral x power n dx is equal to x power n plus 1 divided by n plus 1. What is n value here? As we have x square, n is equal to 2. Substitute in the formula. Integral of x square is x cube by 3. Limit varies from 0 to 2 pi. We keep 1 by pi as it is. Substitute the upper limit 2 pi in the place of x minus lower limit 0 in the place of x. Simplify. This is the value of a0. Shall we find the an? Take down the formula of an. Substitute f of x here. Which method can we use to integrate this one? We are using Bernoulli's integration. Shall we recall the formula? Integral u dv is equal to uv minus u dash v1 plus u double dash v2 minus etc. Here u dash, u double dash etc. are derivatives of u with respect to x. V, v1, v2 are integrals of dv. Here what is u? U is the function which becomes 0 in successive differentiation. So we choose u as x square. dv is the remaining function cos nx dx. Shall we differentiate u? As we have x square, which formula can we use? d by dx of x power n. Tell me the formula. d by dx of x power n is equal to n into x power n minus 1. Here n is equal to 2. So u dash is equal to 2x. Shall we differentiate again? U double dash is equal to, we keep 2 as it is. Differentiation of x with respect to x is 1. Next derivative, u triple dash is equal to We know that d by dx of k is equal to 0 for any constant k. So that derivative of 2 becomes 0. Here we differentiate u thrice so that we are integrating dv thrice. We write integral dv as v. That is equal to integral of the right hand side, integral of cos nx dx. This is of the form integral of cos ax dx. What is the value? Sin ax by a. Here in the place of a we have n. So that we get sin nx by n. Shall we integrate this again? Integral of v with respect to x is v1. So that the next integral value is v1. We keep 1 by n as it is. We are integrating sin nx. What is the integral of sin ax dx? That is equal to minus cos ax divided by a. In the place of a, we have n. So this becomes minus cos nx by n. Already we have a n in the denominator. So the denominator becomes n square. When integrating v1 with respect to x, we get v2. So that the next integral value is v2. That is equal to, when integrating the right hand side, we keep the denominator n square as it is. We are integrating the numerator. Minus cos nx. Keep minus as it is. What is the integral of cos nx? Integral of cos nx is sin nx by n. Already we have an n square in the denominator, is it? So the denominator becomes n cube. Now we are going to substitute all these values in the formula. Replace u value, v value, minus u dash value, v1 value, plus u double dash value, v2 value. Limit varies from 0 to 2 pi. Substitute the upper limit 2 pi in the place of x, minus lower limit 0 in the place of x. What is the value of sin n pi? Sin n pi is equal to 0 and sin 2n pi is also equal to 0. We replace sin 2n pi as 0. What is the value of cos n pi? Cos n pi is equal to minus 1 power n. Here in the place of n we have 2n. So that cos of 2n pi is equal to 1. Again in the next term, sin n pi is equal to 0. So that sin 2n pi is also equal to 0. Sin 0 value is 0. Cos 0 value is 1. But we have 0 outside. When multiplying, the term gets 0. The last term, sin 0 is 0. Simplify this. This is the value of an. Shall we find bn now? To take down the formula of bn, substitute f of x. We are using the same Bernoulli's integration. What is our u here? U is equal to x square. dv is the remaining term, sin nx into dx. Differentiate u until that becomes 0. Just now we have discussed the differentiation of x square, is it? We have the same case here. Shall we integrate dv? We write integral dv as v is equal to integral of the right hand side, integral sin nx dx. We know that integral sin ax dx is equal to minus cos ax by a. Here in the place of a we have n. So integral of sin nx dx is equal to minus cos nx by n. We are integrating this for the next time. Integral of v with respect to x is v1. So that the next integral value is v1. Right hand side, we keep minus 1 by n as it is. We are integrating cos nx with respect to x. Integral of cos nx dx. We know that integral of cos ax dx is equal to sin ax by a. So integral of cos nx dx becomes sin nx by n. So we get minus sin nx by n square. Integrate this again. When integrating v1 with respect to x, we get v2. So next integral value is v2. Shall we integrate the right hand side? We keep the denominator as it is. We are integrating sin nx. Integral of sin nx is minus cos nx by n. So minus into minus become plus. We get cos nx by n cube. Replace in the formula. Limit varies from 0 to 2 pi. We keep 1 by pi as it is. We substitute the upper limit 2 pi in the place of x minus lower limit 0 in the place of x. We know that cos n pi is equal to minus 1 power n. Here we have cos 2n pi where 2n is even. Cos of 2n pi is equal to 1. Wherever you find cos of 2n pi, you make that as 1. We know that sin n pi is equal to 0 for any n. So that sin of 2n pi is equal to 0. And cos 0 value is 1, sin 0 value is 0. Simplify this. This is the value of Bn. Substitute A0, An, Bn in equation 1. Left hand side, f of x is the given function. We replace that here. Substitute A0 value by 2 plus summation n varies from 1 to infinity. An value into cos nx plus summation n varies from 1 to infinity. Bn value into sin nx. This is the Fourier series expansion of the given function f of x is equal to x square defined in the interval 0, 2 pi. Let us summarize. Fourier series expansion in the interval 0, 2 pi is defined as f of x is equal to a0 by 2 plus summation n varies from 1 to infinity an cos nx plus summation n varies from 1 to infinity bn sin nx. We mark this as equation 1. We substitute f of x in a0 is equal to 1 by pi integral 0 to 2 pi f of x dx. An is equal to 1 by pi integral 0 to 2 pi f of x cos nx dx. Bn is equal to 1 by pi integral 0 to 2 pi f of x sin nx dx. We integrate and simplify this. After finding a0, an, bn values, we substitute these values in equation 1. This is the Fourier series expansion of the given function.